Hey, thanks for checking out Next Level Carpentry. With that little bit of routing, I am just now finishing up the range hood I made with the free range hood plans that I made earlier. Well, you will see how to make free plans for making a hood that looks like this. More importantly, this is a video about making the plans more than it is a video about making the hood. Every hood has its own requirements and specifications, so I felt it was more important to show you how to actually make the plans than it was to make the hood. Because of that, I don't go deep into the weeds about making this particular hood, but I do get rather involved in making the plans themselves. It's kind of like that age-old maxim, give a man a fish, he eats for a day. Teach a man to fish, he eats for life. Well, I'm just applying a little bit different twist to that and saying, give a man a set of plans for a range hood, he can build one range hood. Teach a man, or of course a woman, how to make plans for a range hood, and they can make any range hood anytime they want. So that's where this video is headed, and I do hope you enjoy the fishing trip. The range hood you saw in the introduction doesn't even exist yet. The only way it exists is as a fig Newton in my imagination. And to take it from a fig Newton to reality, I need a plan. But because it's a custom design range hood, a plan doesn't exist. So I want to show you how I go from imagination to reality by creating a full-scale plan. I like to draw full-scale plans on a piece that's big enough to contain the whole project, and preferably it's a surface that can be easily erased and that pencil lines show up. And so my material of choice is 1/4 inch MDF with a white coating. And as long as the piece that I have is just a little bit bigger than the biggest dimensions of the project, I'm good to go. I'll apologize right now for putting free plans in the clickbait title because of the implication I'm giving you free plans, but I don't feel it's disingenuous because in reality I'm showing you how to create free plans. And to do that, it doesn't take a whole lot of special tools or materials. I need a pencil. This is a Papermate Sharpwriter pencil, so I can draw continuous fine lines wherever I want to, as much as I want to. A tape measure is good, and a straight edge. Once in a while I need an angle finder, but it doesn't show up on this project. For the 1/4 inch melamine sheet, if that's what you end up using, make sure you sand the edges before you start, because the melamine overlaps the edges sometime, and that's worse than a Ginsu knife. So I always make sure that I run best block for demanding sanding on the edges. Because in an instant that knocks off that sharp cutting edge and I won't end up with lacerations during the project. I often start drawing free plans with a mock-up. You can see here in this picture from the job site where the range hood is going to go that I took cardboard and made that pretty close to scale, pretty close to size, and just stuck it up there on the job site so that the owner and the designer can look at it, evaluate it, and adjust it for proportions. Cardboard is quick, cheap, and easy, and I can get really close to what the final thing's going to look like. And in this case, the cardboard mock-up in that picture is too small. Ended up going with a bigger range hood, but that helped us decide the width and the depth of the range hood, and so the cardboard served its purpose. From there, I often advance to a SketchUp model. That's what this looks like here. That's kind of a proof of concept, and in a lot of times I'll use dimensions from that model for fabrication, but in this case, because of these really slight angles, there ends up being some tricky compound angles and stuff in there, and they're so precise that it's kind of hard to translate them from an actual angle dimension into the actual cuts for the project. So on this type of project, this is generally where I go into the third stage of making free plans, which is drawing a full-scale model. That model gives me all the dimensions, all the angles, all the sizes, all the quantities, everything I need to build with, and I can adjust it on the fly. The range hood here is 30 inches tall. If I get partway through and somebody says, hey, that needs to be 29 inches tall, I can just rework the scale drawing a little bit and all the dimensions change. And often it's easier to mark an angle than it is to measure it and cut it. And hopefully I'll demonstrate how that applies to this project. I find it easier to draw and use a full-scale drawing if I don't start the actual plan drawing itself right at the edge. I like to leave an inch or two around the edges just because it seems to work out better that way. A couple other tools that I use that I didn't mention are framing square. Comes in quite handy quite often. The first thing I do with it is to make sure that my plan surface is square and edges are parallel. This edge isn't square, that one is, so that's my reference corner. This sheet is long enough that I can draw a front view and an end view or a side view at the same time. That's a benefit, although it's not necessary. And the other tool I keep close at hand is a little bit of lacquer thinner and a paper towel, because that serves to erase pencil lines off of melamine like that instead of smudging them around with an eraser. I think I already mentioned that this range hood is a total of 30 inches tall. This sheet is plenty wide, so I'll just start my drawing with a baseline along this edge, and I'm just going to go with 2 inches because I got plenty of room and that works good. When drawing a line along the edge of a sheet of melamine like this, it's essential that the edges are smooth because it'll slice your fingertip in the blink of an eye if you're not careful. The next order of business is to draw a line that represents the height, which in this case is 30 inches. And I'm being mindful of drawing the 30 inches from my pencil mark, not the edge of the sheet. And I'll use the straight smooth edge as a guide for drawing this line as well, because it's faster and easier than using a straight edge. And make sure to read 2 inches on the pencil line I already drew, and then quickly and carefully slide my finger along the edge, holding the tape measure straight, and draw that second line. I get comments from viewers once in a while that give me the idea it's a little bit intimidating to watch lines being drawn this way just by sliding a pencil. And it takes a bit of practice, but it's not as tough as you'd think. And I think it's worth the investment of time of getting used to using that method, especially when you're making your own free plans. It makes the work go quickly, and if you make a mistake, it's no big deal to erase it and do it again because you were able to do it so quickly in the first place. Because the size of this particular range hood is derived from the size of the fan unit itself, I've got to start with that size and work outward, because that unit needs to slip up inside here when it's installed later. Each project has a design direction, and in this case it's from the unit outward. Sometimes there's a certain space what your building has to fit in, so you start from there and go inward. With all that said, I'm going to sketch out the size of that fan unit and how it fits within this range hood. And just because it's simpler this time, I'm going to draw an end view of the hood first, because I've got the plumb line of the wall in the kitchen to work from. I think that'll make sense. I'm trying to draw these lines a little darker than normal so that you can see them. Here's the height of the hood here, the top, and the bottom edge. The line along this edge will represent the wall. Again, I'm going to go 2 inches. This will represent the face of the sheetrock. If I needed to draw the back of the sheetrock, that would be there a ½ inch away. And down in this corner is an example of why it helps to have extra space at the edge of the pattern. This is going to get some tile on it, and I'm going to say that that tile is about 3/8 of an inch thick along with the mastic. And I'm bringing another little square in here just because I can, and I think this one from Greg's Garage needs to be seen to be appreciated. I don't want the fan unit to be directly against the sheetrock here, and I want something for the tile to die into. So I'm going to draw in a piece of 3/4 inch material at the back of the hood that will serve that purpose, as well as be an anchoring point for attaching the range hood to the wall and for attaching the fan unit into the hood. And I'm going to make that about 4 inches tall in the drawing, although that's subject to change without notice. I'll add another 3/4 inch board here at the top of the back of the range hood that'll serve to stabilize the sides of the hood and also provide an anchoring strip for holding a hood on the wall. And a dab of lacquer thinner removes a line to keep my drawing clean. Obviously, every project has its own parameters and conditions, but I hope you can see that you can just build those into your model. It's almost like creating your project virtually ahead of time. It allows you to realize, encounter, and solve problems that come up as you go along. And on this one, as I said earlier, the vent hood thing itself is what drives the shape and the size of this. So I'll continue drawing that into this pattern. The range hood itself measures 19¼ inches front to back. So I'll add that dimension here now. And I'm measuring from the face of that attachment board in the back. One of the reasons I like using full-scale models so well is that I can build reality into my set of plans. So far, the dimension from the face of the sheetrock to the face of the range hood is 20¼ inches. but experience has trained me to know better than to make a dimension that tight. So I'll add a 1/4 inch into the depth of this range to give me a little bit of wiggle room. And that doesn't mean I'm going to end up with a 1/4 inch gap, because this range hood gets covered with plaster, and that plaster is going to fill up some of that gap. I'm going to hold the metal part of the range hood up 1/4 inch from the bottom lip of the hood. So the metal will be right here. And there's a 3-inch tall vertical face on both sides and the front of this hood. So I'll draw that in here and now. I'm lining up 3 inches on the bottom mark there and just sliding that line in. The total height of the range hood is 12 inches, so I'll line that up on the bottom lip and draw another line to represent the top of the sheet metal, which stops at this cleat as well. The front and sides of the range hood tilt in at about 30 degrees, so I'm going to use a triangle to represent that angle here, and then erase these lines to keep the drawing simple. The internal angle of the sheet metal isn't real critical as long as the front face doesn't hit it, so I'm not that worried about that, and that holds true for the piece of 8-inch ductwork that comes up out of this. It's about 2 inches from the back of the hood, runs up into the attic, 8 inches in diameter. So it's about there, and I'll sketch it in just to keep it in mind so that I don't build anything that interferes with it up here. I chose a product called Medex for the angled faces of this range hood because it's virtually waterproof, very stable, and it's relatively easy to work with. I chose soft maple for the vertical faces of the hood. I bought 6/4 stock here that I'll mill down to 1 inch thick because that gives the bottom lip of this hood the look that the designer and the customer are after, and that I'm confident is strong enough for the range hood itself. So next, I'll sketch that hardwood frame into the plan. I could draw these lines with a square or a straight edge, but I'm just going to use the sliding tape measure because it's quicker and easier, and it's plenty accurate. I'm at 20 1/4 inches from the face of the sheetrock to the back of this board, and I'll be 21 1/4 to the front of it. Just like that. The designer wants the vertical face around the perimeter of the range hood to be 5 inches tall. So I draw in a little tick of a mark to represent that 5 inches. And this is the point when the benefit of having a full-scale plan really starts to kick in. When I made the mock-up out of cardboard on site, I just tilted the sides and the face in 5 inches. I didn't determine an angle, I just tipped it in 5 inches. I don't even know what the angle is yet. But with a full-scale plan, I can draw that right in and then measure the angle right here. I can also get that with a SketchUp drawing, but it's so much more simple to do it here and now. And I think you'll see more of the advantage of this method as I continue. But for now, I'll transfer the mark for the front edge of the hood up to the line that represents the top of the hood. Measure back 5 inches and connect the dots. And then I'll offset that line 1/2 inch to represent the thickness of the Medex panel that makes up the front panel of the range hood. And then, by extending the line to the top edge of the pattern piece, I'm able to take a Starrett protractor and measure the angle that I'll use later when setting the table saw and cutting these pieces. And that's telling me the angle is 11 degrees. So that I know my saw setting will be 11 degrees, and measuring the angle the other way, it needs to be 79 degrees. Another benefit of doing a full-scale drawing is that you can get a remarkable amount of detail built into the drawing that helps to visualize and actually build the project. I'll show you what I mean here as I dial in the connection between the face panel and the rim board. First, I erase and retrace a couple of the lines and reestablish the 5-inch height. I use the end of my rule to represent a square edge on the bottom of this front piece. To strengthen the connection between the front face and the front angled face, I want to add a special lip on this piece, and I can draw it in here. And by making the vertical face piece 5.5 inches tall, I can create this little notch or saddle for the angled face to sit into, where I can glue it in place and even add a few screws to make sure the connection is permanent and stable. Anybody that has mechanical drawing experience knows where I'm headed next with this, but basically I'll extrapolate a front view of the range hood from the side view that I just finished drawing. I want to leave a couple inches of space in between the front view and the side view over here, so that's where I'll start. The wide blade of a framing square automatically gives me 2 inches, and I can use that to put my 5-inch mark. And then with a rule, I draw the 1-inch thickness of the face board and 1/8 of an inch space for the side of the range hood itself for that margin of error I talked about earlier. The width of the front of the vent hood itself is 46 3/8 inches, so I'll use my 72-inch rule and lay that out. And then I add in the 1-inch face board for the other side of the range hood before drawing in the 3-inch height of the vent hood itself and transferring the 5-inch height for the face board onto this view of the plan. Then I'll use that Draftsman triangle to draw in the angle on the sides of the vent hood itself. And then I'll draw in a couple of lines 8 inches apart to represent the exhaust duct that comes out of the center of this range hood. And because this end of the sheet isn't guaranteed square, I'll extend the reach of my framing square with a 72-inch straight edge and draw these lines in. Not that it's all that important that they're drawn in square at this point, but to show you how effective it is to use these tools in combination to extend their capabilities. I use the same technique to extend the lines for the sides of this range hood up to the line that represents the top of the range hood, and then offset those each 5 inches in and draw the angles for the sides. And a twist of the lead on that SharpWriter pencil allows me to continue to draw fine lines as long as the lead lasts. I complete this part of the plan drawing by adding the little notch detail in the front board, even though I've already established what that needs to look like in the side view. I'll do it here just because I can. And now I'll add a line across the top of the front view to represent the edge of the mounting cleat that will be installed in the top of the back of the hood. If any additional information is needed for the working model, I can always draw it in at this stage if it has an impact on how the hood is built or installed. For instance, I can draw a line in that represents 5/8 sheetrock on the ceiling, and I could also include wall stud layout or ceiling joist layout if it was necessary to locate the installation screws at this stage of the game. As full-scale drawings go, this is a pretty straightforward one, pretty simple, with not a great deal of detail. But a lot more could be added to the drawing. Rough ends for electrical outlets, if there's circles or curves or hardware that goes on it. All that stuff can be included in the drawing to the extent that it matters for fabrication. But as it is, I've got enough detail in this plan at this stage that I can take measurements off the drawing, figure angles, figure notches, and begin fabricating pieces that make up this hood based on actual dimensions from an actual drawing. Because the focus of this video is how to lay out and draw a full-scale plan for free, I'm not going to go deep into the weeds on the actual fabrication of this range hood. There's other videos here in Next Level Carpentry that show how I go about milling rough lumber into finished pieces, and also how I break down sheet goods. So you can check those out to see the steps that I use for starting the fabrication of this range hood. For now though, I'd like to ask if you like this kind of in-depth content that you'll consider subscribing to Next Level Carpentry if you haven't already. If you find this particularly useful and like the video, hit the thumbs up button while you're at it and help spread the word about this channel, because I don't do Insta, Google, Twitface, so my social media exposure is kind of limited. So anything you can do to share with your friends what you like about videos on Next Level Carpentry, I really appreciate. Tools and supplies you see in use in this video and others here on the channel are in Amazon links in the video description below if you can't find them locally, so check that out. If you have any interest in a t-shirt like the one I'm wearing in the shop tonight, or signs like this that you see around the shop, there's a link to Teespring in that video description, so check that out. Purchases there generate a little bit of sales commission that helps support the channel, another thing that I appreciate. And last but not least, there's a link to a special offer code for Starbond CA glue. Just enter special offer NLC in checkout at Starbond and you get 15% off anything and everything that you buy from the site using that code. They're great products, and I'll be surprised if I get through the video without using a dab or two while I'm building this range hood. But with that bit of housekeeping taken care of, I'm going to get into fabrication here, and I'll pick up the video when I'm ready to apply some of the measurements from this plan to that work. The first fabrication step I'm going to do is to cut the Medex panel down into pieces that'll work for the upper angled faces of the range hood front and sides. From the drawing, I know that one edge of this piece is going to be a square cut and the other edge is going to be cut at an 11-degree bevel. And using a metal rule directly on the full-scale plan, I can see that from the square cut on one edge of this piece to the long point of an 11-degree angle on the other edge, I need to cut these pieces at 25 and 11/16 inches. Because I have a full-scale drawing to work from, I know that the front piece of this is less than 49 inches wide, which is the width of the Medex panel that I have. So I decide to make the front panel and the two angled end panels by cutting them off the end of the sheet, as opposed to ripping one edge of the piece off. And silly though it may sound, another reason I chose to go this direction is so that the scrap I have left over is an end cut that's somewhat close to square versus a long skinny rip, because I think that square will be more useful in the scrap bin than the strip. I'm going to go old school to break down this sheet to make it a more workable size. My sheetrock square is out on the job site, so I go a little bit old school on marking for this rough cut as well. I already know that the dimension I need to end up with is 25 and 11/16, so I round that up to 26 inches and double it, and then mark the sheet at 52 inches for this rough cut. And it's easy to work a large sheet like this down into bite-sized pieces, simply by flopping it on the work surface and lopping one end off with a little cordless saw. Then I set the offcut aside, double check my measurements, and set the rip fence. The next step is to rip this smaller piece in half to give me two pieces with one edge on each at 90 degrees. Notice that I rotate the pieces so the clean 90-degree cut edge is to my right, or your left, on the screen. Then I set the blade to 11 degrees, double check the width setting, and, referencing off that 90-degree edge, rip both pieces to their final size. Now each piece has one edge at 90 degrees and the other edge parallel and at 11 degrees, the exact size I need for the hood's face panels. Then I cut one of the beveled pieces cleanly in half so that I have a left and a right end for the hood that I'll cut angles on later. With the Medex panels cut, I can place one on top of my full-scale plan and see that the angles and dimensions are correct. Using the same process, I can lay out and cut the notch in the top of this face piece of maple, with one exception. I was able to leave the maple 1 1/8 thick because the pieces were nice and straight, so I've got to offset the notch to compensate for that 1/8 of an inch and make sure the Medex panel comes flush at the 5-inch height mark. I'll also need to adjust the drawing by moving these pieces 1/8 of an inch to compensate for that extra thickness, but I'm able to make those adjustments on the fly because I'm working with this full-scale pattern. And it really helps on unique one-off projects like this range hood, where in some cases it would actually be easier to do the range hood drawing after it's done rather than before. As it is, the final plan will be kind of like an as-built drawing rather than a blueprint. Using information from the scale drawing, I can quickly lay out the end of one of these face pieces for the angled notch cuts that I need to make. And placing the pieces on the pattern assures a precise fit at these parts. For purposes of demonstration, I spent a few minutes editing my full-scale plan by redrawing the pieces affected by the increased thickness of the maple pieces. If I weren't doing a video, I would just compensate for this in my head, adding the extra length necessary so that everything still worked out in the final design. And with that bit of editing done, I can measure right off this full-scale plan to see that the total length of the front piece is 48 7/8, and the length of the side pieces are going to be 21 3/8, so that I can cut these pieces with confidence. To further drive home the point of working off a full-scale plan, I'll explain that I decided to compensate for the plaster coating on this hood by modifying the bottom edge of the face pieces. I can do it with a small rabbet that allows for an 1/8 thick plaster without crowding in on the fit of the sheet metal hood liner. I'll do the same thing on the front and the sides, but that does mean reducing the length of the sides by 1/8 of an inch so I don't end up with too big of a gap. So I compensate for that by rabbeting these pieces and then shortening the length of the sides. And a couple quick passes through the table saw followed by a pass with a router give me the finished edge and profile that I need for this face panel. And I can clearly see on the drawing how the back attachment board and the sides of the hood come together. I'm getting deeper into the weeds on this than I intended, but as I look at these pieces, as I fabricate them for assembly, I realize little conditions that come up, and I want this to be a clean connection in the final installation. So I've decided to raise this back member up 3/4 of an inch and then I'll end up with a piece of stainless steel, an L-shaped piece here, so that the stainless steel range hood fits up to that piece of stainless steel angle, and then the tile will butt into the bottom of that. But this whole detail is something I'm able to focus in on because I have all the elements that are involved in the installation drawn out here, and I can improve the final result on the fly. Here you can see how having a detailed drawing makes the project itself go smoother. This is the finished frame here, and all of the details on this frame are represented in the drawing. I was able to anticipate the position of this back beam, this little rabbet in here for plaster, and dial in the final dimension. And I've got 19 3/8 of an inch, so that the 19 1/4 inch range hood will slide up in here. And back here, it's easy to envision how a stainless steel angle will help make the transition between the metal of the range hood and the tile that bumps up underneath here. And that is all what's represented here in the drawing. And I can take the frame itself and just lay it right down on this full-scale pattern to make sure everything looks like it needs to and lines up like it should, so that I'm confident the whole assembly is going to be what it needs to be when it's done. And as I start to build the actual pieces that are represented in the drawing, measurements of the actual pieces takes precedence over measurements that are on the plan. But as long as dimensions from the actual piece are what they need to be, it's all good. And you can see that here with this overall inside dimension of 46 5/8 that allows a comfortable fit of the range hood at 46 3/8. Because dimensions from the actual piece take precedent over dimensions from the drawing, I measure the width of the front of this hood at 47 15/16 inches. Then I transfer that measurement to the piece that I roughed out for the face, reduce the overall dimension by 5 inches on either end, connect the dots, and then use my old school track saw to make initial angle cuts to cut this piece to its initial size. And after making those angle cuts, I make an initial fit up of these panels with confidence because it was all laid out beforehand on that full-scale plan. Not bad for an initial fit up, if I do say. I mentioned earlier in the video that I didn't use SketchUp to calculate the angles and the dimensions for this particular project because with the slight amount of tilt, those angles vary by so little, it's almost meaningless to take that dimension from SketchUp and try to apply it to the real project. And at this point, when I need to make a piece to fit into these corners, I think you'll see what I mean. Admittedly, I'm getting off in the weeds on this bit, but I'm sure viewers will be curious about how I joined these panels together to complete the range hood. I know that mathematically, this corner is not a true 90 degrees, but the corner of this square is. When I put it here, you can't really tell that there's anything amiss there. It might be a single degree less than 90, but between the full-scale pattern and this physical example, I know that I can make a corner filler block here that's 90 degrees and everything is going to work out great. And that's important here because I want to use a filler that's bigger than a 1/2 inch by a 1/2 inch. So I'm just going to slide these panels back so that they're 1 inch from this corner, make a filler strip, and then trim these panels to a final width or length so that everything lines up with the frame, which is the final dimension that I need to end up with. After cutting corner blocks exactly 1 inch square and marking 2 faces for the front, I cut 1/8 inch by 3/8 inch grooves in 2 edges of each corner block, and then marking and indexing a face on the Medex panel, I cut a matching slot in the angled edge as well. And with splines cut in 2 faces of the corner blocks and the mating edges of the face panels, I can use 3/4 inch by 1/8 inch splines slipped into the slots to hold the panels and the corners together in perfect alignment. With my proof of concept corner mock-up complete with slots and splines, I can place the assembly in place on the base frame to mark the exact locations where the panels end and the corner begins. I use these marks for a final precise measurement for the front and side panels, trim them to size, and then dry fit the panels with the corners, and then drive a few screws that will hold everything in place during glue up. And that's starting to look an awful lot like the pattern. A little strategic trimming at the corners of the face where the corners of the upper panels meet gives me a nice, clean, intersecting fit of the 5 different pieces that come together at these corners. The bottom ends of the corners get a compound 11-degree angle cut to meet up with the sloped top edges of the face frame for a nice, clean fit. With the corners and panels all trimmed and fit up, it's easy to cut and install the brace that'll go across the back of the top of the hood to maintain the shape of the hood and to provide a cleat that'll hold it to the wall. And now the back of the hood looks just like I anticipated it from doing the drawing earlier. I've got one more member to cut and fit and install across the front of the hood to keep that front panel sturdy, but then the assembly is ready for glue up. Into the front cross member and easing the edges with a 3/16 round over bit finishes up the fabrication part of the range hood build. So I think I'll wrap up the video at this point, and I hope you can see with this finished assembly here how I take a project from a fig Newton of my imagination on a full-scale plan to a piece of reality, which is this range hood. You notice I screwed everything together with no glue. Everything will get glued up so that these seams are solid and tight, because this ultimately gets a plaster finish, and I don't want any cracking on these corners and edges. Naturally, I'll fill these screw heads with a little bit of Bondo, and the whole thing will get primer for the plaster that's going to go on here to stick better. I got so engrossed in finishing up the build on this range hood that I neglected to mention Patreon and all the patrons who go above and beyond to help support Next Level Carpentry. Everyone on this list has made a pledge of support, and that support goes a long way to help me justify the time I spend making videos like this, which naturally I appreciate. By becoming a patron, you'll have access to behind-the-scenes videos from Next Level Carpentry, from the shop, from the job site, and anecdotes about life. I just finished shooting one of those videos here just a few minutes ago. Because each of these people goes above and beyond to support the channel, I've kind of made it a habit of showing their names on an appreciation list at some point during the video, and this is it. For everybody else, you get to see what the range hood looks like now that the holes are filled. It's all sanded, it's ready for primer, and then a multi-step plaster process that it'll get. Having mentioned that, I'll cut back to the regularly scheduled outro for this video. So I've got to get in and clean off all this guy glitter that I got covered with during the project and glue it up, and then I'll shoot the intro to the video, kind of a back to the future sort of thing. And so, as always, until next time, thanks for watching. I really did want to do this whole build video outside in the sunshine, under the shade of some trees in the summertime, because that way I would have built a free range hood instead of just a plain old range hood.